Thank you for this opportunity. I wish I could be there with you in person, but unfortunately, I'm not able to travel at this time. What I want to do this morning is give you a quick update on an ongoing project. It's our Rapid Integrated Damage Assessment project. I want to begin by acknowledging our team members, Eric Yamashita, Junath Gimiri, Jeho Choi, Lily Bui, and Lydia Murakawa, part of the University of Hawaii National Disaster Preparedness Training Center Pacific Urban Resilience Lab team. And what I want to do is describe briefly our data models and some of the applications that we're developing and using for 3 different recent disaster cases, and then describe some of the challenges that we've had with integrating and processing data, and then close by talking about some of the research and training and educational needs. We've all had to adapt to the pandemic. For us, this has meant re-engineering some of our technologies for tasks like determining whether or not people were wearing face coverings or masks. The ecosystem for rapid damage assessment is quite complex. There's a need for quick information on damages to support optimization and prioritization of actions to support disaster response and recovery. And there are many, many partners that come together from the state, local, federal governments, and others as well too. And so what this project is about is to create a platform for integrating data from many different sources, which I'll describe. So what we're doing with this is taking pre-existing databases on the exposure, different models for estimating the likelihood of damage, and then collecting data in real time to merge with pre-existing census, land use, other database, and then using that to do rapid integrated damage assessment to support decision-making and planning in response and recovery. Now, this really is challenging because there are activities that need to be carried out before, during, and after disasters occur. We need to create a database which has pre-event data. And this tells us where the population is located, where the travel behavior occurs, and then we can pull that together really quickly with an assessment of the exposure to get a sense of what happens during a disaster. And we're trying to collect real-time information from diverse sources, from social media and conventional media sources, satellite aerial imagery, and then analyzing that imagery to be able to provide real-time or close to near real-time data as these events unfold. Part of our research involves conducting field surveys to prioritize locations, and then a lot of post-processing where we're using machine vision and learning for classification of different damage levels and exposure. We had severe flooding on Kauai in 2018, heavy rainfall and extensive flooding throughout Kauai and on Oahu from April 13th through April 15th. And there was localized damage to roads, bridges, public facilities, structures, and homes. Where we often begin is looking at the FEMA damage declaration data, and then the public and individual assistance claims to start with some sort of base in terms of the initial damage assessment. And then what our project entails doing is sending teams with equipment out into the field to collect imagery on the ground using drones, and then also with the same technologies that Google is using, Google Street View, so that we can compare the Google Street View imagery to real-time assessments of the damage or repair work that's being done. We've been doing a lot of work in the 2018 flood, also the volcano, which occurred at the same time in Hawaii, to collect information about how these tools and technologies can be used to assess damage, but also monitor the progress towards recovery. And so our project involves integrating the existing Google Street View imagery. And if you look at the bottom, that's the Google Street View imagery. I believe this is from 2017 imagery. And then what we can do then is compare that to the imagery that we collected following that at various stages. And so these tools are available, and I can send you information about these platforms. In 2021, we had Hurricane Ida, which was a Category 4 storm that struck the Gulf Coast. And it had wind effects, storm surge effects, but also it became a major rain event with flooding and also tornadoes in Mississippi, Alabama, Tennessee, Kentucky, and the East Coast. So again, we've compiled information to look back at this event and then also use this to test our technologies. Again, beginning with the publicly available sources of data and information about where the requests for public assistance, individual assistance have occurred. Part of what we're doing with this project is creating a composite score for estimating the likely risk of damage based upon different databases and sources of information. And then what we do is estimate the likelihood that a particular census tract or area is damaged. And so all of this can be done without the actual damage data, but based upon the storm track, the intensity, other types of information. And so this shows an estimate of the likelihood of a damage by a census tract according to this composite score. And then what we do with this is acquire satellite imagery, other types of imagery that have been collected just after the storm, to be able to compare our initial assessments to this. And so this shows the pre and post impact satellite aerial imagery, which we have integrated with crowdsourced media reports, and then compared this data with our modeled estimates of damage to the built-in natural environments. A big part of what we're trying to do is to combine together machine vision, machine learning algorithms to be able to better classify the types of damage, the location of damage, the intensity of the damage. And this requires that we actually go out into the field to collect data and then confirm some of the analyses and then using various types of technology to do this. And so what I want to show you quickly is some of the street view imagery and then the 360-degree imagery that we collected from Grand Isle and other parts of New Orleans, other parts of Louisiana following the storm. Again, the bottom imagery shows the Google Street View imagery, and then the top image shows the imagery that we collected. And you can see one of the challenges about getting real-time information. The storm had lingering effects, and it's challenging to capture good imagery because of the rainfall and other harsh conditions. And so we're using YOLO to classify the imagery into none, moderate, and severe. And so far, we have about a 75% accuracy of the classification. And so, we took thousands of images and then classified them into these different categories of damage or levels of damage. And then what we're doing that is using that to train the algorithm to be able to spot and classify the level of damage. We've also been applying these techniques and methods to the recent tornado event. Again, this really is work that's currently underway. The storm occurred on December 10th through 11th. Reports of 52 different tornadoes, as well as wind and hail events. 18 counties in Kentucky were impacted. Kentucky, Tennessee, and Arkansas all declared states of emergency. And again, we begin first by looking at the public and individual assistance claims, and then relate that to other on-ground surveys and sources of damage. And we're looking at critical infrastructure first, looking at large facilities. There was a warehouse distribution center that was impacted. And then looking at the effects or impacts to lifelines, to shelters, water systems, wastewater systems, energy communications, and obviously roadways is a big function. And again, the idea is to bring together diverse information about building footprints, roadway networks, the land cover, socioeconomic data, and then other socioeconomic data about disability, minority status, housing types, to assess the social and physical vulnerabilities to bring together into our damage assessments. And then again, producing composite maps, which show the likelihood of damage, integrating that with survey imagery, and then also with our Google Street View equipment. And this shows some of the actual damage equipment, the damage in the heavily impacted areas. And the idea is to integrate this research into our training courses to build capacity. We have several courses at the National Disaster Preparedness Training Center. We have various reports that are underway related to damage typologies and then progress towards the recovery from these various disasters. Overall, I want to conclude by saying that this approach gives a non-invasive methodology for collecting information to identify communities with a high likelihood of damage even before the event occurs. There are some challenges in terms of the availability, accessibility, and then the inconsistent format for data. And then we are trying to use this technology for confirmatory analysis and prioritization. And I think there are real opportunities to combine together machine vision and deep learning. This proof of concept needs more extension, and we need to reach more first responders. Obvious gaps that we've encountered in terms of getting timely, accurate, usable, actionable data. There's always been a challenge in terms of integrating science or lab work or prototype work that we're doing with actually policymakers and first responders out there. We also need to have better systems for archiving data, archiving lessons learned and shared systems. There are issues about who owns this data, who controls it, data governance issues, especially with these emerging technologies and capabilities. We need more funding for research and development and testing. And obviously this relates to many of the big challenges that we face in terms of not just response, but longer term planning, mitigation, and recovery from disasters. I think that there are strategic opportunities to focus on transportation systems, to do better integration between FEMA, USGS, NOAA, NASA, Google, others. I really recommend that we focus on key pilot areas for research and development, like Hawaii. And I hope that there can be greater collaboration and convergence across disciplines. And we need to invest in smart systems, green infrastructures, systems that are safe to fail. I think that there are strategic opportunities with the infrastructure bill, with building back better, with investing in human capital to address these ongoing problems and threats associated with climate change, with the need for more equity and readiness, and long-term workforce development. So with that, I'd like to stop and hope that you can join us and visit us soon, and that we can see each other in person. Thank you for this opportunity.